Okay, welcome back there, folks. This is part two of the rate of change video, and this is actually example one. And I promised you that we'd return to this example, the self-esteem example. Um, I've got my graphing calculator there, and hopefully we'll make good use of it. Calculate the average rate of change over this interval. So this is from 20-year-olds to 35-year-olds. And part C is to interpret this, and so we're going to actually do that as we go. Um, Notice that we could handle this in exactly the same way that we did the last example, because remember, we do have the function, right? There's the cubic function. So this is kind of like our f at x. And so we could do f at 35, subtract f at 20, and so on, right? So one way to do this would be solution, get this so it's a little bit smaller here, would be the A rock is just f at 35, subtract f at 20 over 35 minus 20. And I could use the function that I came up with yesterday to do that. Notice I'm not going to do it that way because I've got graphing technology. I've got the calculator here. Why wouldn't I use it? And that's a good question. Why wouldn't I use it? So if I go hit the trace button, you see how I'm a little spider on one of the points that I typed in, this one here. I want to be on this curve. So I'm going to jump up to the curve. This is y2, which is actually y2 is that line that I put in last class. I got to jump up to the curve. There's the curve. There's the big, long, nasty curve there. And I'm going to type in 35. And hopefully it'll jump right to 35 on. Yeah, it does. 8.9 and change. 8.902 about. Subtract f at 20. On the bottom, that's just 15, right? And so I'm going to put in 20, and it should jump me right to 20, which is 11.80 about 796. And then I do that calculation, and I get an answer of about negative 0.1929. And what are the units here? Well, remember, our y-axis, our change in y, was percent self-esteem, right? So this is percent of self-esteem. And what's my x values? The change in x is years per year. So what does this mean? This means the percent of people reporting low self-esteem is going down by about 0.2% per year. So low self-esteem reporting is decreasing because the average rate of change is negative, is decreasing by about 0.2% per year over those years. By the way, I think that makes sense, right? So 20-year-olds are just getting, in university and stuff like that, and they might be struggling a little bit with finances or future or with family or whatever. By 35, I think most people would probably be more established and probably have higher self-esteem. So it makes sense that the percent of people reporting low self-esteem would be decreasing over those ages. I think that makes sense. Dandy. Part B, estimate the instantaneous rate of change at x equals 50. So notice one thing that we could do is exactly what we saw before, and I'm gonna, write down my new fancy formula again, right? Where this h is as small as I possibly can have patience for. And I'd pick x is 50 and h is whatever. And so I could do it the same way. Now, I'm not going to do it that way because I do have my graphing calculator, and I have a slick way to do this on the graphing calculator, and I want to share that with you. There is a built-in feature of the graphing calculator that draws the tangent. And I think we've seen this before, but I'm going to go through it again. If I hit second and then draw, and I'll write these steps on there, and then tangent 5, it's expecting me now I have to put in what point I want the tangent at, and I want it at 50. Press enter. Bam, right there. There's x equals 50, and there's the tangent line. All right, so I'm going to grab a copy of that, just so I don't have to go back and forth and copy that out. Down here. And I'm going to write those calculator steps so you can practice those in class. So what did I actually do there? I went second, program. So I hit the second button, and PRGM, which is actually the draw menu. And then I selected 5, which was tangent, hit 50, and then enter, and it drew this tangent for me. And notice there's the equation of the tangent, negative 0.146x plus 13.08. Right? That's the equation of that tangent line. That's pretty slick because there's the instantaneous rate of change. It's the slope of the tangent. Remember, IROC is the slope of the tangent, which is equal to negative 0.146 about. And what does that mean? That means self-esteem, low self-esteem reporting is decreasing still by about 0.15% per year, and that's for 50-year-olds. Right? And it's only when it looks like maybe around age 60 or so that the percent starts going back up again. All right, that's example 1, which is actually our second example today, using the graphing calculators, and you'll mess around with those in class. Those are a couple examples for you to try. Another boring old one here, estimate the IROC of this function when x equals 3. Notice we could sketch this really quickly if we wanted to, but that's not what we're asked to do. We're asked to find the IROC. And I'm going to use this just to do another chance to do my fancy new formula. This x plus h minus p at x over h. Right? And this is the idea. Instead of using x1 and x2, I can use my x value and my h as small as I possibly have patience for, right? And, you know, I know that 0.1 is good, 0.01 is better, 0.000000001 would be better, but who's got patience for that? So I'm going to, this is, I usually use 0.01 as being close enough. So, and this is essentially a calculator exercise. And if you're slick on your calculator, you might be able to put this entire thing into your calculator all in one step. I'm going to use a little bit of rough work here. So this is 3 minus 2, and just substitute in 3, right? That is clunk, 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 calculator, 42. And we know that this is going to be close to 42, and it is. It's not exactly, but... And if you're good on your calculator, that number you could put in exactly in your calculator here, in all its decimal places, and be as accurate as possible. And when I subtract 42 and then divide by that, I end up with 55.1401, and it's kind of hard to see the pattern there, but it looks like it's around 55. It appears that the IROC, which remember is the slope of the tangent, instantaneous rate of change of P at x at x equals 3, is about 55. No units in this case because this is just a plain old boring function. All right, we got a bunch for you to try there and an FAQ, and finally we're done with polynomial functions. And then so we've got some review and tests coming up shortly. You probably know the date already, but if not, you should be bugging me and your classmates about that. Okay, that's it.